Okay, problem 25 is all about practicing our constructions from our construction unit. We have 4 different constructions that they would like us to be able to find. I'm going to do A, B, and C, and D. For A, I need to find the perpendicular bisector of a segment. So I'm going to take a segment, let's call it AB, with endpoints A and B, and I'm going to take my compass. Take your compass, put it on one of the endpoints, it does not matter which one. Open it up, an amount, it does not matter how much, it just needs to be more than halfway. And I'm predicting that this is about halfway. So open up your compass and swing it so that you have an arc that goes all the way through the line. Take your compass point, put it on point A, swing it, keeping it the same distance that you just used, so that you have an arc that goes all the way back through and crosses with your original arc. We are then going to connect the point where the 2 arcs meet. And this segment, I'm going to label it CB. Is both perpendicular to and bisects segment AB. So that was construction A. Construction B, we need to bisect an angle. So I'm going to start off just by making an angle. Let's label this angle. We're just going to label the vertex B. Okay, I'm going to put my point of my compass in vertex D and open my compass an amount. It does not matter how much. I'm going to draw an arc so that it intersects both sides of D. I'm going to label those E and F. You're then going to take your compass, go to point E or F. I'm going to go to F first. Open it however much you want. You can even keep it the same measure that you just used, and draw an arc inside the angle. Keeping the same measure, move it over to point E, and draw another arc inside the angle. These 2 arcs need to intersect. Then connect point D to your new point. I'll call it G. And segment DG now bisects angle EDF. All right, construction number C, letter C. Ask me to draw a line parallel to another line through a given point. This is going to use the concept of corresponding angles to create these parallel lines. Here I have a line, I'm going to call it line L, and I have a point not on the line, I'm going to call it point P. We start by connecting point P to line L with any angle line you want. I'm going to use this. We then attempt to copy one of these angles that we have with our line and line L. One of these angles we're going to copy up here to point P. I'm going to copy the big angle. So I'm going to take my compass, put it on the point that I am now labeling A, where our line intersects line L. And I'm going to draw an arc using A as the center. Take your compass with that same measure, put it on point P, and draw another arc. This arc has to intersect your line, which is really going to be your transversal, above point P. Down below, your arc intersected both the transversal and the line. So I'm going to label these points B and C. And I'm going to measure the distance from B to C with my compass. Okay. Now I'm going to go up to where our arc intersected the transversal. I'll call that point D. I'm going to put my point on point D, and I'm going to draw another arc that goes through the arc you just created. Where these two arcs intersect, I'm calling it point E. That's our new point that we are going to connect to point P. To hopefully make a pair of parallel lines. As you can see, sometimes it works, sometimes it doesn't. But in this case, as long as the construction is correct, you are fine. All right, finally, construction D asks us to find a point equidistant from 3 given points. So we're kind of imagining we have 3 random points in space, and we want a point that's equidistant from them all. These 3 points form the 3 vertices of a triangle. And something that is equidistant from 3 vertices is the circumcenter. As you should hopefully remember, the circumcenter is equidistant from the vertices. In order to create the circumcenter, we're going to have to do the perpendicular bisectors of 2 of the sides, find the circumcenter, and then draw, and then find where that is, and that will be equidistant from the 3 points. Okay, I'm going to kind of do that down here. Okay, down here I have generated a triangle. I am about to do the perpendicular bisector of 2 of the sides, just like you saw me do for construction A. This will give me 1 of the perpendicular bisectors. And I'm going to do another perpendicular bisector. As you can see, I did not go far enough. I need those 2 arcs to intersect. Okay, as you can see, right about here, the 2 perpendicular bisectors intersect. So this should be the circumcenter of my circle. I'm just going to check that it is the circumcenter of my circle by measuring the distance from the circumcenter to a vertex and drawing my circumscribed circle. And as you can see, due to the fact that the circumcenter is the same distance away from all of the vertices because the radius is the same, this must be a point equidistant from the 3 distinct points.